This Zoom session has been brought to you by the Fractal Hex Rouleau Triads. For today, we'll be doing section 6.4 and 6.5. 6.4 is about simplifying complex fractions. It's a fraction which is a fraction made of fractions. 2/3 divided by 5/7, for example. Or reciprocal of x plus the reciprocal of y. Or 2 over x plus 5, all that divided by 3 over x plus 1. The idea is to try and turn it into a simple fraction, expression divided by expression, with no divide signs within each expression. For just pure fractions divided by fractions, a over b divided by c over d, the simplest trick is to simply invert the second fraction, so it's d over c, and times that by a over b. Then you multiply across ad over bc. So for example, 2/3 divided by 5/7. That's the same as 2/3 times 7/5, multiplying across. 2 times 7 is 14, 3 times 5 is 15, and there you have it. And these don't have any common denominators, common factors, so that's where this stands. This is a little more complicating. 18x to the 5th over 3y squared, that all divided by 2x to the 8th times over 21y to the 5th. Like we take the numerator, 18x to the 5th over 35y to the 2nd, and times by the reciprocal of the denominator, therefore 21y to the 5th over 2x to the 8th. Then you multiply across 18 times 21, x to the 5th, y to the 5th, 35 times 2, x to the 8th, y to the 2nd. Now, all right, the coefficients you multiply out and you distribute, and you multiply out and you find common factors and reduce the lowest terms, is 27 over 5. Here we have x to the 5th over x to the 8th. 5 minus 8 is a -2, so we put x to the 3rd in the denominator. Here we have y to the 5th over y to the 2nd. 5 minus 2 is a 3, so y to the 3rd in the numerator. So 27y cubed over 5x to the 3rd. Here, we not just invert and multiply, but we also cancel common factors. If it's not just simply fraction over fraction, but more complicated thing like reciprocal of sum of reciprocals, which incidentally there's an extra credit set for in the extra credit set module. I call this operation reduction. Anyhow, it's sort of addition standing on its head with the roles of numerator and denominator switched. Now, so this thing, 1 over x plus 1 over y, we rescale, we multiply above and below, by the product of what I call the inner denominators. This has a denominator of x, this is a denominator of y, so that product is xy. So we'll multiply above and below by xy. And the numerator is 1 times xy. So then the denominator we distribute, get xy over x plus xy over y. After some cancellation in the denominator, we get xy over y plus x, product over sum. Here, 2 over x plus 5, all that over 3 over x plus 1. The inner denominators here are x, so we rescale, we multiply above and below by x. 2 over x times plus 5, all that times x is 2 plus 5x. 3 over x plus 1, all times x is 3 plus x. So 2 plus 5x over 3 plus x. Here we have a really nasty one. 1 over a minus 1 over b, all that divided by a over b minus b over a. All right, the denominators are a and b, so we rescale by ab, multiply above and below by ab, and then distributing thus accordingly, you get ab over a is b, 1 over b times ab is a, so b minus a in the numerator. Here, a over b times ab, the b's cancel, leave an a squared. B over a times ab, the a's cancel, leave a b squared. B over a divided by a squared minus b squared. Now this is a difference of squares, which factors into a difference times the sum, a over b times a plus b. Now here we have a b minus a, and here we have an a minus b. These are in subtraction in opposite order, and they're opposite. B minus a is the opposite of a minus b. Now the a minus b's cancel, leaving -1 over a plus b. Here we have 2 over x plus 3 minus 1 over x minus 3. All that divided by 3 over x squared minus 9. Now this x squared minus 9 is a difference of squares. It factors into x plus 3 times x minus 3. So we have denominators x plus 3 and x minus 3. So multiply above and below by that product. And this times this, the x plus 3's cancel, leaving twice x minus 3. Minus this times this is x plus 3. And this times this cancels, leaving just a 3. Now in the numerator, we just distribute and combine like terms. And a couple steps later, we get x minus 9 over 3. And here we have 2 over y minus 1 minus 2 over y is the numerator. All that divided by 3 over y minus 1 minus 1 over 1 minus y. Now these are in opposite order subtraction. So we can swap this around, 1 minus y to y plus 1, and we change the sign, 1 minus to a plus. Now these two terms have common denominators, so they combine to 4 over y minus 1. That's underneath 2 over y minus 1 minus 2 over y. All that over 4 over y minus 1. The inner denominators are y minus 1 and y, so we multiply above and below by y times y minus 1. For this 1 times this, the y minus 1's cancel, leaving a y. For 2 over y times this, the y's cancel, leaves minus twice y minus 1. Here, the y minus 1's cancel, leaving 4y. Now this in the numerator, after distributing and canceling the two y's, you get 2. That's over 4y. And there's a common factor of 2, which cancels, leaving 1 over 2y for the answer. It seems a relatively simple answer after this complicated beginning. A lot of these problems are in fact like that. They start out looking complicated, but it's, well, for example, this. 1 over a plus 1, that plus 1. All that over 3 over a minus 1 plus 1. Okay, the inner denominators are a plus 1 and a minus 1, so we'll multiply above and below by that. A plus 1, a minus 1 over a plus 1 here, plus 1 times a plus 1, a minus 1. This is 3 times a plus 1, a minus 1 over a plus 1, a minus 1, plus 1 times a plus 1, a minus 1. Okay, the a plus 1's cancel here, leaving an a minus 1. Difference of squares gives you a squared minus 1. The a minus 1's cancel here, leaving 3 times a plus 1, plus a difference of squares. Okay, this we expand out to 3a plus 3. This is a squared plus a minus 2 here. Here, the 3 minus 1 is a 2, 3a, a squared plus 3a plus 2, underneath a squared plus a minus 2. Now this, if you factor, find two numbers whose sum is 1 and whose product is negative 2. A plus 2, a minus 1, that works. This, we can factor up similarly to get a plus 2, a plus 1. Now we have a common factor of a plus 2, which cancels, leaving this, a minus 1 over a plus 1. All right. That concludes